Let's take the first activity of your textbook. Here we have to take a magnesium ribbon and we have to burn the magnesium ribbon. The precaution while doing this reaction is you have to rub the magnesium ribbon with the sandpaper so that a layer of magnesium oxide which was formed on the ribbon previously will be rubbed off and it will going to react very fast with the fire. Now when you burn magnesium ribbon, you will get a white color powder which is nothing but magnesium oxide, and the equation is this: magnesium plus oxygen gives you magnesium oxide, and then you have to balance the equation. Make sure that whenever you write an equation, you need to balance the equation. Now coming to the next question, what do you observe when potassium iodide Ki solution is added to a lead nitrate PbNO3 solution in a test tube? So white lead nitrate react with the white potassium iodide. You can see the solution here, lead nitrate and potassium iodide, they are white in color. Okay, or here it looks transparent, but they are white in color, but when you mix them you will get a yellow lead iodide solution which is insoluble in water. So the reaction goes here: PbNO3 plus Ki, KNO3 and Pbi. So lead iodide, and the yellow color is nothing but our Pbi, that is lead iodide, Pbi2, lead iodide. So you can see initially the color of the lead nitrate and potassium iodide is almost colorless, and when you add them you will see the change in color. So when you see the change in color, it means a certain chemical reaction has taken place, right? This is an identity of that a chemical reaction takes place between the two solution. Coming to the next activity, is there any change in the temperature when water is added to calcium oxide? Calcium oxide is quicklime, CaO, or in a beaker. When you add water to calcium oxide in a beaker, here you can see a person is touching the beaker. That means there is some change in the temperature. So the question can be asked on this type of activity. If possible, you try to draw a picture like this and then you can answer it. Here the answer is calcium oxide reacts vigorously with water to produce Slade's lime. Slade lime is calcium hydroxide. So you have to write down that reaction is a vigorous reaction. It is a exothermic reaction because when you touch the beaker, you can feel that the beaker has become little hotter, right? Here is the chemical equation: calcium oxide plus water gives CaOH whole twice. Fine, it is the balance equation. So in this reaction, calcium oxide and water combines to form a single product. This is again a example of combination reaction, right? And we know that most of the combination reaction, or almost all the combination reaction, are also exothermic reaction, right? So it is example of exothermic reaction as well as it is an example of combination reaction. Clear? Here you can see the one single product you got when you add the two reactants, right? Such reaction in which a single product is formed from the two or more reactant is called combination reaction. So this answer you have to write in detail, and this can come for 3 marks. Let's take another example, another activity, and the question based on the activity. Do you observe any change in the color of ferrous sulfate crystal when they are heated in the boiling tube over the flame of the burner or the spirit lamp? If you take a ferrous sulfate crystals, initially they are green in color, right? Because they are FeSO4.7H2O, it has water molecule. So initially it is green in color, but when you heat it, it will change into white color, right? And this white color is anhydrous ferrous sulfate, FeSO4, and you still heat it, then you will get ferric oxide, which is brown in color. You can see in this picture it is brown in color, right? Initially it is hydrated ferrous sulfate, and it has 7 molecules of water, but when you heat it, first initially it will become white in color, ferrous sulfate, and you heat it again, it will turn into ferric oxide, which is brown in color, right? And sulfur dioxide gas is also released, and sulfur trioxide gas is also released. So ferrous sulfate decomposes to form ferric oxide, Fe2O3, and sulfur dioxide and sulfur trioxide. So the gas emitted smells like burning sulfur. In this reaction, the single reactant FeSO4 decomposes to form 3 different products. So we can see a single reactant decomposes to form 3 different products. So it is an example of decomposition reaction. So children, whenever they ask you in the exam that you have to give the example of decomposition reaction, you can give the example of ferrous sulfate. Okay, and you can give this example. And let's take the next question. What is decomposition reaction? We have already seen what is decomposition reaction, where the reactants break down into more than 2 and more than 2 compounds. Then we call it a decomposition reaction. This can take place with the help of heat. So this is a typical example of thermal decomposition reaction. Now we will see the different types of thermal decomposition reaction in the next slide. Here comes the next example of thermal decomposition, right? Here we have taken calcium carbonate, which is heated. I can put a triangle sign also, which means that we are heating this. We are using heat in this reaction. So when you heat calcium carbonate, which is in a solid state, you are getting calcium oxide, which is nothing but quicklime, and which is a major constituent of cement industry, right? And here we were getting 2 products, that is calcium oxide and carbon dioxide gas is released, right? Coming to the next question. What do you observe when a boiling test tube containing lead nitrate powder is heated over a flame? So when you heat lead nitrate, PbNO3, this powder, you are getting lead oxide, okay, which is a yellow solid residue. You will find it, it is it will remain in the test tube, and there is something which is coming out in a form of a gas, that is nitrogen dioxide as well as oxygen, right? Nitrogen dioxide, it is in a form of a gas which is brown in color, right? So brown fumes of nitrogen dioxide you will see, and it has a very typical irritating smell. So this is how you can identify the nitrogen dioxide. Now coming to the next question. During the electrolysis of water, we observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tube, right? If you see this bubble, if you see in fact this test tube very carefully, right, at anode, that is which is a positive electrode, at cathode, which is a negative electrode, right? We know that when water breaks, hydrogen will be collected at cathode, right? And oxygen will be collected at anode. Clear? And when you see the hydrogen which is collected at cathode, you will see there is a more amount of water displaced by a gas. That means here the hydrogen produced is more as compared to the oxygen, right? Clear? So why, in fact, why hydrogen is going towards the cathode? Because when water breaks, hydrogen H plus ion is formed, and when yes, the other ion will be O2 negative oxide, right? That is why hydrogen is moving towards the cathode, which is negatively charged um, electrode, and oxygen will move towards the anode, which is a positive charge electrode, right? And you can see the difference in the volume of the two gas. And if I write a formula of H2O, there is, in this, two hydrogen molecules are present and one oxygen molecule is present. So definitely the amount of hydrogen gas is more as compared to the oxygen. So you can read the answer carefully later on, pause it, read it carefully, and you can write the answer. Okay, here, other than that, we have another experiment. Now this type of experiment, again, it is a decomposition of water, and this is a decomposition of water with electricity, so we call it electrolysis of water also. Okay, and in the next picture you can see the silver chloride is turning gray in presence of sun. So this is again a decomposition reaction, okay, which is taking place in the presence of sunlight. So what are the different types of decomposition reaction? You should know the different types of decomposition reaction. Okay. What happened to the color of the silver chloride when it exposed to sunlight? Silver chloride turns gray. Initially it was silvery white in color, but when it exposed to sun, it get decomposed, it changes into silver, which is gray in color, and chlorine gas is released. Okay, so this is due to the decomposition of silver chloride. This we have already discussed. Now this type of decomposition is called photodecomposition. We can call it photolysis. Lysis means break. What do you mean by lysis? Lysis means break. Photo means light. We know that photosynthesis is another word. Okay, synthesize, that is different, that is making, producing something. Lysis is just opposite of synthesize. Decomposition of silver chloride. Here is the chemical reaction, and one more reaction is there, silver bromide. Okay, silver bromide again get decomposed in presence of sunlight. You will get silver and bromine gas is released. So whenever in the exam, if they ask you about the photo decomposition, you have to give these two examples with equations. Coming to the next, two test tubes are taken and labeled A and B. About 10 ml of copper sulfate was added to, so these two nails you have to clean it by rubbing with sandpaper, were immersed into the test tube B and left undisturbed for 20 minutes. Okay, two nails. But here in this picture, I could able to get this picture. I have shown only one nail. That's fine. Compare the intensity of the blue color of copper sulfate solution in test tube A and test tube B, right? You can see let us take the first test tube as A and the other test tube as B. In the B test tube, I have put a nail for 20 minutes, right? And you can see the change in the color. Initially, the copper sulfate solution is CSO4, it was blue in color, and later on it get faint, and here you can see it is clearly a green color. Now this green color is due to the displacement reaction. Iron is more reactive than copper, so copper is replaced by iron, and because of that we are getting another solution which is nothing but FeSO4. Okay, so FeSO4 is green in color, that is why we are getting FeSO4. And what is the other observation? The other observation, you can see the fine particles of copper got deposited on the nail. So whenever you got this type of question, you have to get this type of question, you have to write the two observation, and then you have to write the equation, and you have to mention this type of reaction is a single displacement reaction, or else you can write displacement reaction, right? So this is the example or explanation of the same. reaction. Let's take the next question. What happened when 3 ml of sodium sulfate solution is mixed with 3 ml of barium chloride? Sodium sulfate Na2SO4 and barium chloride BaCl, right? Here you can see both are salt. Both are salt. Now how do you identify that they are salt? See, in the salt, children, the first in the salt, the first element will be definitely a metal and the second will be a radical. Okay, here also barium is a metal and chloride is a radical. So in most of the salts, the first will be the metal and the second will be chloride. There can be a salt with the inorganic substance also, but just in a case you don't get confused, I'm giving you a little bit of tip over here. So here both are salt, and definitely you will see there will be a displacement of metals away, and when sodium displaces barium, we are getting NaCl, sodium chloride, right? And this in the place of sodium, barium will come. Okay, so you will see there is exchange of radical. Okay, there is exchange of radical from both the compounds, and we are getting two new different compounds over here by the exchange of radicals, because there is a double displacement, so we call it a double displacement reaction. Okay, when 3 ml of sodium sulfate solution is mixed with 3 ml of barium chloride solution in a test tube, a white precipitate barium, we know that NaCl is it is in aqueous condition, and above all NaCl is a salt solution which doesn't have any color, but barium sulfate, it is white in color, so you will see a precipitate over here. And we know that a double displacement reaction is also known as a precipitate reaction. Double displacement reaction is also known as precipitate reaction. And what is the other name of a double displacement reaction other than the precipitate reaction? Yes, neutralization reaction, right? That is a neutralization reaction. So this is an example of double displacement reaction, children. Here I have shown you another picture of the displacement reaction. This is a single displacement reaction where you put a zinc metal sheet in copper sulfate solution. You will find initially, of course, the copper sulfate solution was blue in color, and later on you will see it has become very faint, and you will find a blackish crystals over here. It is not looking brownish crystal because these crystals of copper are very fine. So the color is literally black, in this color is literally black, and this is due to the deposition of the copper which was initially present in copper sulfate solution. Zinc, being more reactive, displaces copper from copper sulfate solution, right? This is example of single displacement. And here you can see another example of displacement reaction, lead with copper chloride, and copper will be replaced by lead. Okay, we are getting lead chloride and copper. So these two are extra example of single displacement reaction. Let's take the next example, children. What do you observe when we heat a china dish containing copper powder? So we will find that when you heat copper powder, you will find that it is coated with black copper oxide. It means the color of copper oxide is black. Okay, and what is the reaction taking place over here? I'll write the reaction: copper plus oxygen, and when you heat it, I'll put a triangular sign which depicts that we are heating this solution, we are heating this, and copper oxide is formed. Let's balance the equation. 2 oxygen over here, copper is 2, and here also we have to put 2 to balance the equation. So we get copper oxide. Now when we pass hydrogen over this copper oxide, here is the reaction. When we pass hydrogen over this copper oxide, what are the changes we are finding? We see that copper dioxide, okay, which is initially having oxygen, is converted to copper. It means the copper dioxide is losing oxygen. Here there is a loss of oxygen. You can see there is a loss of oxygen. And what do you mean by loss of oxygen? Loss of oxygen means copper dioxide is reduced, right? Loss of oxygen means reduction reaction. Loss of oxygen or gain of hydrogen is a reduction reaction. Here if we see hydrogen, hydrogen is gaining oxygen. Okay, so hydrogen is getting oxidized and copper dioxide is getting reduced, right? So oxidation and reduction reaction taking place simultaneously. So these type of reaction are known as redox reaction. I'll take one more example from your book. PbO plus carbon gives Pb plus CO2. So we can see it here clearly that lead oxide, okay, change into lead, it means it has lost oxygen. That means it is reduced and in the next case carbon atom got oxygen and we say that carbon has oxidized. So first is the reduce and carbon got oxidized, right? So I can write here oxidation reaction taking place. Oxidation, it's ation. So here also oxidation and reduction reaction are taking place simultaneously, and we call these type of reaction as redox reaction. Coming to the next activity, what happened to zinc granules when diluted hydrochloric acid or sulfuric acid is added to it? Is there any change in its temperature? Zinc, being an active metal, radially react with hydrochloric acid at room temperature to form soluble zinc chloride and hydrogen. Okay, zinc will definitely react with acid, but you cannot perform this reaction with sodium and calcium because that will be a very explosive reaction. We can perform the reaction, but only thing we need to take a lot of precaution for that. So zinc, what will happen then if zinc reacts with the hydrochloric acid? Definitely we will find the bubbles of gas is coming out, right? And which gas is this? Definitely it is a hydrogen gas which is coming out in the reaction. We can see this zinc plus HCl, so doesn't Cl2, it is the compound which is forming and hydrogen gas is getting released. Clear? So this hydrogen gas, it is collected by the delivery tube, and you can see that it is collected in a soap solution. Okay, when it is collected in a soap solution, you will find the bubbles coming out. When you bring a burning splinter near to it, they will produce a pop-up sound. Can hear a pop-up sound. So wherever you hear a pop-up sound, that means surely that is a hydrogen gas. This reaction is a exothermic reaction. Make sure that, because they have asked in the question, there will be is a change in the temperature. Yes, there is a change in temperature, and temperature has increased because of the release of heat, and so the flask become hot and temperature of the system increases. So here is this activity and question based on this activity. Here comes the next activity. Describe an activity with diagram to illustrate that the reaction of metal carbonate and metal bicarbonate with acid produces carbon dioxide. So this is the aim of your activity. Write the relevant equations for all the reaction that takes place. Name two forms in which calcium carbonate is found in nature. So this is in fact a question of 5 marks. And because you have to write an activity, you need to write in a proper steps. You have to first start with aim. Now aim is to show acids react with metal carbonate and liberate carbon dioxide. These are the materials that you have to mention uh, over here. Now the procedure is you have to take a marble chips in a Wolf funnel and Wolf bottle, sorry, set the apparatus as shown in the diagram. And you can see here thistle funnel is attached. This is a Wolf bottle, and in this you have taken hydrochloric acid and calcium carbonate. What is this calcium carbonate? Nothing but marble chips. The gas is collected over here, and it is we are passing this gas to lime water. Okay, so definitely there will be a change in the color of lime water. The color of lime water will become milky. There is another method over here where you can bring a burning splinter, and when you bring the burning splinter it will get extinguished. So this is a clear sign that carbon dioxide is released in this reaction. And then you have to write the procedure we are going to see in the next slide. Okay, you have to pour HCl with the help of thistle funnel, and then you have to collect the gas in a gas jar by the upper displacement of air. Then you have to bring a burning matchstick near the gas jar and record your observation. Pass the gas, evolve through it and pass it into lime water. Then you have to again note down the observation. So observation, it has to come down. In fact, okay, fine. Observation will be the burning matchstick get extinguished because carbon dioxide is doesn't support combustion, right? Then lime water turned milky. This we have done, and you have to write the proper chemical reaction. Even though if they don't ask in the question that you have to write chemical equation, wherever you are doing any kind of activity, remember that you better write the chemical equation. Okay, chemical here is the chemical equation: calcium carbonate and HCl, diluted HCl. When it react, calcium chloride is formed, that is white precipitate, water, and carbon dioxide gas is released, and you have to balance the equation finally. Then lime water, that is slake lime, passing carbon dioxide to lime water, calcium carbonate will be formed. Because of the calcium carbonate, you are getting that milky type of appearance. Okay, and water is also formed. Conclusion you have to give, or you can write inference: metal carbonate react with dilute acid to liberate carbon dioxide. And the last part of the question we have, where you have to give the calcium carbonate found in nature, that is in the form of limestone, chalk and marble. Okay, they are the different form of calcium carbonate. So when you get the question like this, especially the long questions, you make sure that you have written the answers of each and every part of that question. Okay, all metal carbonates and hydrogen carbonates react with acids to form the corresponding salt. Here calcium chloride is a salt, corresponding salt, water and carbon dioxide, right? So this you have to learn. So this is all about today's session, children. We have done a lot of activities, and there are many equations. Please practice this equation, try to balance this equation, and you need to concentrate more in your studies and work hard. Thank you so much, children.